The question we are solving now belongs to test series 1. It is of control system subject. In specific, it belongs to Routh-Hurwitz analysis of control systems. As per the question, the block diagram of a control system is as shown in the figure. The control system takes an input of R of t and it has the g of s as k by s into s plus 1 into s plus y. This is the feed forward transfer function, and the feedback in the control system is the unity negative feedback. It is given that the value of k is chosen such that the control system produces sinusoidal oscillations for unit impulse input. It is given that for unit impulse input, the output contains a sinusoidal oscillations and the value of k is chosen accordingly. We need to find the frequency of oscillations. We need to find the frequency of oscillations. We see that the overall transfer function can be written as T of s is equal to g of s divided by 1 plus g of s into h of s, and here h of s is equal to 1. From this we can see that T of s can be written as k by s cube plus 6s square plus 5s plus k, and s cube plus 6x square plus 5s plus k is the characteristic equation of the control system. Upon performing the Routh-Hurwitz analysis of the system for marginal stability, we can form the Routh array as shown. The coefficient of s cube 1 is put here, the coefficient of s square 6 is put here, the coefficient of s 5 is put here, and the constant term k is put here. Now, by finding the elements at the points marked, we see that the element at the first point marked is 30 minus k divided by 6, and at the second point marked it is just k. Here we see that for marginal stability k is equal to 0 or 30, but it is given that k is greater than 0. From this we see that for marginal stability k equal to 30, here we get some sustained oscillations in the output of system for unit impulse input. So from this we see that the auxiliary polynomial can be written as 6x square plus 30 is equal to 0, that implies s square plus 5 is equal to 0. Upon substituting s is equal to j omega, we see that the auxiliary polynomial gets simplified to minus omega square plus 5 equal to 0. That implies omega equal to root 5 radians per second. From this we see that if the value of k is chosen for marginal stability, that is for k equal to 30, the output contains sustained oscillation with a frequency of root 5 radians per second. Hence, the correct option for the frequency of oscillation is D.